Hello, and thank you for taking an interest in my OpenBSD firewalling course. This course is geared toward the beginner, and it runs for 10 sections. Over the course of those 10 sections, we're going to start with the very basic introduction to what OpenBSD is, and some things about it, all the way through things like the requirements you need to build a firewall, over how to configure PF, some monitoring day-to-day, and then we're also going to have a bonus section with a few more topics in there to help you better secure your network using OpenBSD. I do hope you enjoy this course, and again, I thank you very much for taking an interest, and have a nice day. Welcome to Section 1. In this section, we're going to lay the groundwork for what OpenBSD is. So, it is a security-focused operating system, and it is actually based on one of the BSDs that is called NetBSD. So it actually forked from NetBSD originally. And it's founded and led by Theo Durat, and it was first released in 1995, so it's been around for quite a while. And in that time, it's gained a very good track record as a secure operating system. Now, it is open source, so you can see the source and the ongoing progress on services like GitHub, and they also have their own CVS interface on their website. And one of the very nice things about OpenBSD is it has many built-in networking functions. So after you install the operating system, you don't have to go around and install the different software packages for most networking things. Most of them are included. So it can serve many needs in an organization's network. Things like DNS, DHCP, web, email, firewalls, routers, and many more. So you'll find a lot of good uses for it. Now, another thing to realize, the entire system has and continues to be designed with groundbreaking security features. So the security features range from things like managing your memory more securely. They have things like address space layout randomization that will help stop certain exploits in programs. You have more security with mounted file systems and what you can do with them. They secure programs with things like veil and unveil and things like pledge, which is a very interesting way where you can have that program run, but you can strip away some permissions of it and functions that it can do. So it might not be able to, after it's done a certain task, read files again in a certain place. That would be an example of things they do, but they do very many things. For the security of the system. So that does lead into that it is a very well-suited system for a firewall or server in a very hostile environment like the internet. So that is a basic introduction to it. And in section 2, we're going to talk about the requirements to build a firewall with it. So I will see you there. Okay, moving right along to section 2. Now in this section, we'll touch on some requirements for any firewall. So, first of all, we need at least 2 Ethernet NICs. So you need 2 interfaces that can run Ethernet, and they need to be the RJ45 type. So, the next thing is the internet connection requirements. You can use this with cable, DSL, fiber, or satellite internet connections. The main thing is that the modem you're provided, whether it's home use or enterprise, that modem should have an Ethernet port on the back of it that is RJ45. So you should be able to plug the other end of that cable in there. Other than that, I would recommend at least 1 Ethernet switch, because you want to connect things like your other computers and servers and things into the network, along with your wireless access points and other things like that. Now, as far as the computer that's going to be the firewall itself, you want at least 2 gigabytes of hard drive space. Now, mind you, that 2 gigabytes won't give you that much room. So in reality, these are the very bare minimum. Now, as far as the CPU of that computer you want to use, you can use any 32-bit or 64-bit Intel or AMD CPU. You can use others, but those are probably the most supported. As far as the amount of throughput and bandwidth, these specs, the specs you need for that, I would say anything equal or less than 100 megabits per second, you can get by with a 400 to 500 megahertz CPU and 32-bit with about 128 megabytes of RAM to 256 megabytes of RAM. Now, mind you, unless you are doing a huge amount of traffic, the RAM requirements, see, when OpenBSD processes packets, its networking stack is in the kernel, and when it starts up, it actually allocates RAM for packet buffers, the routing table, and other things like that. So unless you're running other services on top of the firewall, you won't see a benefit from increasing the RAM. I mean, you're not going to hit any limits with that. So increasing the RAM, don't think that's going to make it go much faster, because those buffers and everything are prearranged by the kernel. So again, though, if you're doing more throughput, if you need more throughput, think about 100 megabits per second through to 1 gigabit per second plus. I'd recommend a 1 gigahertz CPU and with a gig of RAM. Now again, because when you're doing more things, you can tweak the firewall state table size as well as the amount of buffers, the buffer size for packets, and that would take up more RAM. So the faster you want to go in general, you're going to want more CPU horsepower and you're going to want more RAM. But the amount of RAM doesn't directly affect the throughput. Again, those are things that are pre-allocated in the kernel. So anyway, though, with that, we're going to move right along to Section 3. Okay, so in Section 3, we're going to discuss how to install OpenBSD. So OpenBSD does support many CPU architectures. So basically how your CPU processes information. And it can range from a 64-bit CPU all the way through to Spark 64, ARM 64, many more. The main ones we usually use are AMD 64 and i386. Those are the main ones. But the cool thing is, OpenBSD does offer 3 main methods of installing it. So that's a lot of flexibility, depending on what you're dealing with. So the first method, you can copy they call it the install.fs file, and the 2 X's there are just the version number. But you just take that file there and copy it to a USB stick. And again, we are going to talk about this in a lab after this video, so don't worry too much about that stuff yet. But you copy that to a USB stick, and then you can boot your computer off that stick. Now, mind you, too, when I keep saying computer, I mean, you can definitely build a very powerful server for this, with redundant power supplies, ECC RAM, 2 physical processors. You can do that with OpenBSD just fine. So you can also use an ISO. You can just burn the ISO file to a CD or DVD. And you can do the really cool option of using the pre-boot execution environment. And you can download the PXE-boot file to a TFTP server on your network. And then you configure DHCP to point to that TFTP server and the file. So then your clients could boot up OpenBSD from there and install. And I can tell you, too, where that would be really helpful is, networks where you have a lot of firewalls you have to deploy, or you have a lot of branch offices where you may want to spin up 50 firewalls, all for that service. But those are some of the ways we can install OpenBSD. And in the next video, we're going to hit the ground running with a lab. And, just break down the lab real quick. We're going to go on OpenBSD's website, show you around a little bit, talk about how to download the file, and touch on how to create the media. So I will see you in the lab. Let's get into it. Okay, in this lab, we're going to download OpenBSD. This will work with any modern web browser, but I'm using Firefox in this case. So in your search engine, you want to type OpenBSD. And in the results, you want to click OpenBSD, and you want to make sure it is openbsd.org. Now, the two main ways you can get to the download is you can click here, but that you need to click a few more links after doing that. But the most straightforward way is probably under Getting OpenBSD here. Click the download, and you'll see the files, the ISO file we talked about earlier, and the FS file as well, and those architectures. So, again, how we talked about. We're going to download the ISO, so to do that, we just click the architecture we want of that file type, make sure Save File is selected, and then hit OK. And at that point, that starts the download. But if you need a site closer to you geographically, you can click Mirror Sites, and then you can scroll through the list of mirrors here and pick one closer to you, like Canada in this case. You would just click the current release version, and you can find the architectures here in the same way. You see we have our same ISO file here, the FS file is there, and also here's the PXE boot file we discussed for booting over the network. So that's how we download OpenBSD, and in the next lab we're going to get it installed, so I will see you there. Alright, in this lab we're going to install OpenBSD. So after we boot our computer up with it, it goes ahead and starts to boot up and detect all our computer's hardware. And then once it's done, in 1 second here, we're presented with the install menu. Now the main option we want to use is the install. So we want to type I and then hit enter or return. And the first option for your keyboard layout, it all just depends what keyboards you happen to have. If you don't know, you can just hit the question mark, and that will show you your available options. In my case, I'm going to choose US. And after you type your option, you can just hit enter or return, and that is how you tell the installer what you want to do. The system host name is going to identify the machine on the network. We're going to give it test here. You can for sure give it whatever domain name you are using. You don't want to use special characters though. That is one thing. You don't want to use any special characters on that. Okay, our network interface is for our internet connectivity. We're going to use EM1 in this case, but if you just have one interface, you can just hit enter. That's okay. And this is how it will get its address on boot. And the DHCP is fine in our case. That just means it will automatically get it. And again, later on, we'll go into this in more detail, what it's doing. All right, it got a lease. And for IPv6, we'll just say none, so just hit enter. And we are done configuring our interfaces. All right, our domain name, we'll just accept the default. Again, if you have a need for a specific one, you can go ahead and put that there. Now, this is our administrator password. So the root account in Unix is like the administrator if you come from Windows. So we want to type a very secure password for this user. All right. Now, SSHD allows us to use the internet to log into this machine and administer it. So just like we were sitting right in front of it, we would have all that access. And in this case, we are going to disable this. So we're going to say no here. And the X window system is really good if you're using this as a desktop. That gives you a graphical interface to use. But we don't want that for a firewall, so we're going to say no. And our user is a separate user account that will be a separate account we do our day-to-day operations in. We'll choose test in this example. It can be any name you want. The full name is okay as the default, unless you want to put something else. Important here is make sure you use a complex password, but make sure it's not the same as root's. So if this account is compromised, the root account is still secure. So we're going to choose a different password for this account. And here's the time zone for your time. And in here you can just type question mark if you didn't know and find the one you need. This one is fine for me, so we'll just accept it. This is where it will install all the OpenBSD files too. If you have multiple hard drives, you can hit question mark and you can go ahead and select the one you need from there. If you choose to install from a USB, do make sure you're not accidentally installing to that USB. So do make sure you're selecting the right one. But we're fine with this choice. So we're going to hit enter. We want to use the whole disk. And this is telling us how it will partition and format the hard drive. We're perfectly fine with the automatic layout. So we're going to go ahead and accept it. And now this is formatting and, well, partitioning and formatting the hard drive for us. So once we're done, OpenBSD will, be ready to use the hard drive. Okay, the sets are the different parts of OpenBSD, and we can get them a variety of ways. The main thing to remember is CD0 is probably the best way if you don't have an internet connection. If you have an internet connection, you can use HTTP. But important, if you boot off USB, you have to either use HTTP or disk, because you have to point the installer to the right place, because you won't have CD0 if you use a USB stick. But in that case, you would just type disk. But in the demo, we used a ISO, so I'll just type enter here. You can choose the default path. That is okay. In the sets here, we do want to not install some of them. So to do that, we're going to type minus. And then looking at our sets, we don't want any of the X sets for the X window system. So it's called Xorg. So we want to type X, and then we want to type star. And that means X, and then anything after that we want to deselect. So if we hit enter after typing those 3 characters, that takes away all the Xorg sets. We want to do the same thing with the games, so minus G star and then enter. And the same thing as well with the compiler, so minus C star, and that takes it off for us. So you'll be left with BSD, which is the kernel, BSD.RD, which is the RAM disk, the base, which is all of the software, and the man pages. Now, if you have a dual-core CPU or a quad-core, you'll also see a set called BSD.MP for multiprocessor. In that case, leave that set selected, because you may get better performance with the multiprocessor kernel if you have a CPU that is dual core. So that's something to watch out for, but we're okay with these choices. So we're going to say done. Now this is normal. The ISO doesn't come with the signature file to verify the checksums, but if you use HTTP, that will pull that down for you. So if you don't feel comfortable with this, use HTTP and it will have that for you. but we are okay with this, and we know we got it from a legitimate source. So we're going to say yes and enter. And now it is installing the sets to the file systems it made. So after it is done here, we are almost done with the entire installation. But this can take a little bit depending on the speed of your system. So I'm going to go ahead and pause the video, and I will see you in 1 second. Okay, the sets are all done. And you do have the option, if you forgot something, you can just type those again. Disk, DHCP, whatever you want to start installing them again. But we'll say done here, so just enter. Sets are timed correctly. And now it's got its last few configurations. And really cool, it will create a unique kernel now for every time you do a specific update. Or any major thing, like if you update the system or when you first install. But it all makes it harder to exploit. Alright, so now all we have to do is reboot. So for that, we just hit enter. Do make sure to remove your CD or USB stick though. Otherwise, you'll end up booting back up into the installation. Alright, so that is this section done. And in the next section, we're going to start learning about a little bit of the admin housekeeping we need to do. So I will see you there. Okay, now that we got OpenBSD all installed, we're going to go over the basic housekeeping we got to do to make sure the system's running well. Now, the first thing I would recommend is sometimes you will find hardware in your Ethernet NICs and things that is proprietary and has to have firmware installed to operate. This isn't as common as it used to be, but basically we do that with the fw_update command, and we run that as root, and we already discussed root in the lab as we were installing. So that's, you would run all of these commands as root, by the way, as the administrator. So next we'll discuss keeping things up to date with syspatch. This installs binary patches so you can save time when you're updating the system. And then we'll go over user management, adding users and groups, removing users and groups, changing passwords, locking user accounts, which is important when you have things like brute force attempts happening, how we discussed SSH, how it can be a security risk. That would be a reason you would lock an account. Also, we'll discuss starting and stopping services, and finally, installing and managing programs. And don't worry though, because all these labs are coming up next. So I will see you in the labs, and we will start working through it. Okay, in this lab, we're going to learn how to install firmware with fw_update. So the first thing we want to do is log in as root with what you gave it during the installation. And what we want to run is simply, well, first, before we run this, always make sure you have a network connection. So you want to run ping space and then any domain name that, Google or whatever you want. Just make sure you have connectivity. So after that, we can just type clear there to clear the screen. You want to run fw_update and hit enter. And in this case, actually, there is nothing to install. But if there was something to install, it would simply download that for you and install it. So that's how fw_update works. Again, this is good for things like wireless cards that need firmware, Ethernet network cards, and also your CPU's microcode firmware can be installed with this command. But that is how we use fw_update to install any needed firmware in OpenBSD. So that is this one, and I will see you in the next one. Alright, in this lab, we're going to install updates with the syspatch command. So the first thing you'll want to do, again, is test that you have connectivity with ping. And we do. And after that, you can run the command sys patch, hit enter, and it should start to install the patches. And depending on the speed of your connection and things, it will take a little bit. And there we go. Okay, this will take a little bit of time, but basically, when OpenBSD has a vulnerability, they will fix it, and instead of you having to patch the source code and recompile the system, these are pre-compiled patches for you, like the programs themselves. So it's an easier way to fix it much quicker than recompiling the entire system. And again, after updates, it just creates another unique kernel for your system. And the last thing you should do after running any update is reboot the system, since some of the old programs that could have been updated, especially things like the network stack or anything to do with encryption, you'll want to reboot to make sure the old files are not still running in RAM with the vulnerabilities. So we're going to go ahead and reboot, and that is how we use syspatch. So I will see you in the next one. Okay, in this lab, we're going to do user management. So, in this case, we are logged in as root, and we want to add a user called test2. Okay, so to do that, we want to do add user, and then type enter. Now, in this case, where it says enter username, we're going to go ahead and type what we wanted, so that is test2, hit enter, and the full name can be the user's name, but anyway, we could just type test2. Here's what we're going to do. We'll accept the default shell, and the user ID is okay to leave default. The login group of test2 is good. And we do want to invite test2 to the wheel group. Now, in this case, you do have to realize inviting the user to the wheel group does mean they can become root with the su command. But in this case, we are assuming this is like another administrator account that we trust. There's more secure ways to do that, but they're outside the scope of what we're doing. And we're going to accept the default login class. We're going to enter a password, but again, make sure it is separate from any user on the system, especially the root user. And this is asking us to verify if it looks okay. And in this case, it does. So we're going to type yes. And we don't want to add another user, so we're going to say no. And now, to verify the change took effect, we'll be able to exit from the root account. And if we type test2 and then type that password we gave it during the creation of the account, we are now logged in. You will also notice when you're not root, it is not a number sign. It is not a number sign, it is a $sign. So we're going to do who am I, and we're test2. And if we do pwd for print working directory, we are in the directory /home/test2. So that is how we create a user in OpenBSD. And in the next video, we're going to look at how to remove that user. Okay, in this video, we're going to remove the user we created previously. So we are logged in as root again, and if you recall, the username was called test2. So we want to do the command rm user, hit enter, and then it's asking for what username to remove. And again, it's test2. If we hit enter, this is verifying the entry to remove. And that huge string there is the hash along with those other parameters we gave it when we created. So we're going to say yes and hit enter. And we're going to say yes to removing the home directory of the user. And now the user is fully removed. So that is how we remove a user. And remember, in those prompts, do make sure to type the letter Y for yes. Okay, so we're going to clear it here. And in the next one, we're going to look at changing user passwords. So I will see you there. Okay, in this video, we're going to look at how to change the password of a user. So there's actually two ways from which you can do this. We're going to do the first one from the root account, and this is what you would do if the account was being broken into or you wanted to enforce that the users change their password. So right now, if I exit, and I did remake the user from before that we just deleted. So test2, and we log in with the password of test. And we're able to log in, okay? But if we log in again as root, and now we're going to do that password command. So we're going to say pass wd space and then the username, test2. If we hit enter, it's going to ask us for that new password we want to use. We're going to say test1, test1. We're going to type it again because it won't like that we're using these passwords, but if you just keep typing them, it will allow you. Okay, so test1 is now his password, but if he tries to log in now as test2 with test as the old password, it will not work. Again, to verify, it doesn't work. So he would have to get in touch with the administrator and type test1 to be logged in. And as you can see, you can also see the unsuccessful login attempts as well. Alright, so say the user doesn't like that. And when they log in, they choose to change their password. Well, we can do, as the user logged in, pass wd and just hit enter, and you'll change your password. Now, this can be administratively prohibited, obviously, but for this lab it isn't. So we'll say test1, and now our password will be test3, and again, it won't allow, it doesn't want us to type that, but in production you do want to use more complex passwords. So now if we exit and log in as test2 with test1, which was the password we put on as root, it doesn't work. And if we log in with the password the user chose, it logs the user in. So that is how you can manage passwords. Again, the user can, by default, do them from their own account, but they can only change their own password unless they're a member of the wheel group and then can become root. But root can change everyone's passwords globally. So with that, in the next video, we're going to talk about how to lock accounts to secure them against password attacks. Okay, in this video, we're going to learn how to lock and unlock user accounts. So we're going to run off the assumption that the administrator found out what test2 did by changing his password. Not very happy about it. So right now, if we do test2 and test3, which is what the user chose, we can log in. But if we log in as the administrator and run the command user mod space dash capital Z space and then the username test2, that account is now locked. So if we log out and try to log in as test2 once again with the password he gave himself, it will not work. So there we go. We keep trying to log in even with other passwords that he might have typed at some other point. Not going to work. So to unlock this account, we will do user mod dash capital U and then the username, test2. Now if we log in again as that user, we can use the original password. Now another interesting thing we could do, if it was for reasons that the password wasn't complex enough, we can lock the account, then inform the user why we locked the account, and then while the user knows that, we'll unlock the account, and as root, run the password command on the user's account, and type a much more secure password, then tell the user you have to use a more secure password in the future to log into the system. Now they accept that and log in. So that is how and why we lock user accounts, and it's not just for password policy compliance, it is also for things like brute force attempts like with SSH. But that is how we do that, and I will see you in the next one. Okay, in this video we're going to learn how to start and stop services. So we're going to use SSH as an example, and there is a few main things to know. So the main way to manage services is with the command rcctl, and again we do have to be root, or at least be in the wheel group and become root to run this command. But we use rcctl, and if we want to enable SSH on boot, we would do enable space and then the service name. So that is SSHD, and that enables it. And now after doing that, if we reboot, it will start on boot. But we want to actually start it right now, so we can do rcctl start SSHD, and now it's started. And now if we do rcctl stop SSHD, it is now stopped. And to disable the service on boot, we do rcctl disable SSHD. So that is how we manage services on OpenBSD. So I will see you in the next one. Okay, in this video, we're going to go ahead and learn how to install and remove programs. So what we do to do this, first of all, we got to realize about a file that controls this. And it controls your package mirror, which is where you get your packages from. And probably the quickest way to see it is use the command called less, which is a pager, and we're going to do the file in etc called install URL, and it is set by default on installation in newer versions of OpenBSD. But if you want one closer, just like we did when we downloaded OpenBSD, you could just type the URL of that mirror. So it's straightforward. But first of all, how do we search for software? Well, we can do something like package info space dash capital Q. This remotely will search the mirror for us. And in this case, we're going to use if top as our argument. And it should search it for us. There we go. Now to add the program, we do package underscore add if top. Hit enter, and that should install the program for us. But it also will install any dependencies as well. But what we do after it's installed is we can do package underscore info, and that shows us the packages that are installed. But how we go ahead and remove those is with package delete and then the name of the package. Alright, and that will remove it, and it's also telling us to remove some groups. But that's how we do that as well. But the other thing is, if you have bigger packages, you'll want to do the tech A with package delete. That will do an automatic removal. So actually real quick, let's look at the man page. So man package underscore delete. And if we look at the -A switch, that deletes the unused dependencies. So if we do package delete and pretend if top has 10 other packages needed, and we do a -A, that will delete any unused packages. That will come in handy later when you install bigger packages that leave over a lot of other dependencies. But that's how we install and maintain software. So I hope you enjoyed that one, and I will see you in the next one. Okay, now that we got all our housekeeping taken care of, we're going to finally get into the network-related configurations. So the first thing is how to configure interfaces. So the main thing is, all interfaces that we would want to configure, we configure them under the etc directory in a file called hostname dot and then the interface name. Now, breaking that down, the X portion is all dependent on the driver in use, and this just depends on what OpenBSD has to manage that piece of hardware. But for instance, your Intel network cards would usually have the EM driver, whereas something like a Realtek network card would have the RL driver, but that would affect what X is. So the number after that, though, does specify the interface to configure, because you can have multiple interfaces that have to use the same driver. So you have to differentiate the configurations with that number. So when we type commands in the file, each directive that we give the file is passed to the command called ifconfig, and that's the command that manages our interfaces for us, and we can run to put things like IP addresses on the interfaces. But by putting them in that file, though, it does this automatically every time OpenBSD starts. So if we put an IP address on there, it will just do that every time the operating system starts or reboots or what have you, and we don't have to worry about maintaining that. But if you are testing things or want to test a change, you can make those changes take effect immediately without rebooting with using the command sh, which is the shell, and then you give it the argument etc netstart. That will parse the files for you and run it on those interfaces. So that is a quick way to test the interface changes before you put them in, to stay. You could still take them out if something went wrong and revert back. And since they're normal files, you can copy the hostname files as a backup before you make a change, and then if the change didn't work, just copy the backup file back to the original. But that's it gives you some flexibility there. It is different if you're not used to working with it, but it does have some flexibility with it. So, up next, we're going to break down the syntax of the file, so I will see you there. Okay, so now we're going to talk about the syntax of the file, those hostname files. And the main thing is, when we want to configure an IP address, we configure a init, okay? And that specifies that you're setting an IPv4 address on the interface. For IPv6, it would be init6. But in this case, we have init and then a space, and then it would be something like 192.168.1.1, and that's the IP address we want to configure and assign to that interface. Following that, you have a subnet mask. So in this case, we have 255.255.255.0, so /24. That tells it the mask to configure, but it has to be the IP address followed by the subnet mask. So some examples, init again for the IPv4 address, and then that basically says that it's the 192.168.1.1 address we want on there, and the subnet mask of 255.225.225.0, which is a /24 CIDR, but that configures it for that network, and that puts that interface on that network. Now, another neat trick, if you want to run a command that with ifconfig, or any command really, you can prefix that command with an exclamation point and then run a command. So if we have a static internet connection where we assign a static IP address, and most business internet connections are like that, you can use !route space add space default, and then after that add an IP address. This adds your default gateway for your static WAN that you would have, your static IP address. And this would be the static gateway, so any packets that are in this interface, you would have that address, part of this network, and you would just send it out toward that next hop. But that would be how you would specify that. Otherwise, you can also, if it's a home connection or you just don't have a static IP, you can use Dynamic Host Configuration Protocol, and in that case, all you have to do is type DHCP in there. But don't worry, we're going to do a lab on both of those coming up right next, so I will see you in the lab. Alright, in this video, we're going to set up our interfaces. So what we want to do first is we can use ifconfig to find the names, how we talked about before in the interfaces section, that, EM is the driver and the number is the interface to configure. So EM1 is actually configured from the installation previously. So we're going to back the file up with the cp copy command, hostname.em1. We'll back that up to hostname em1.back. You could also give that a certain date if you were testing changes. We'll remove the original file, and we're going to start with a basic LAN and WAN configuration for our firewall. So EM0 is going to be our LAN, and EM1 is going to be our WAN. So we're going to start with etc hostname.em0. And for our LAN IP address, we're going to use init for IPv4. We're going to type 192.168.1.1 space and then our subnet mask of a /24. We want to hit escape. Now, by the way, to edit, we use the vi command, and to edit in vi, we just hit I for insert, and then we can start typing what we want to type. X will delete a character for us, and if you type D twice, it will delete the line. But to get out of edit mode, we just hit escape, and then we can save the file. Now, to save the file, use the shift key and do the colon and type WQ for write and quit, and then hit enter. So that made our first file for us. So for our second one, that was EM1, we're going to use EM1. And right now we're going to pretend we have a static WAN IP address. So in this case, I'm going to use init 192.168.43.254 with a /24 mask. And underneath this, we're going to use our command there. So to type any command, we're going to prefix it with an exclamation point and do route add, and then default, because it's the default gateway, and our default gateway is 192.168.43.1. And now to make all of this take effect, we're going to do the command sh space etc net start. Okay, everything came up, and if we run an ifconfig, we will be able to see that everything is up and running, and we can ping. So that is how we set a static WAN address and a default route. So how we also set a dynamic one, we would just go back into our WAN interface file. We can just use the type D and then type D twice to delete those lines. So double tap the D. And what we're going to do is type DHCP here, escape, and then save the file with WQ again. And then we're going to use sh space etc net start. And now it just comes up automatically with an address over DHCP. And we still have connectivity. But that is how we manage our interfaces and set them up for a LAN and WAN configuration, either statically or with DHCP. So I will see you in the next one. Okay, now that we have IP addresses configured on our interfaces, we need to discuss how do we route IP packets between those interfaces. So in this section, we're discussing IP routing. So very basic. IP routing is the process that sends packets out the correct interface. And how it does this is it looks at the destination IP address of the IP packet's header, and it compares that with entries in its routing table. If it finds a matching entry, or the best matching entry, also known as the longest prefix match, it sends it out that interface toward that next hop. But if no match is found, a destination unreachable message is sent to the sender of that packet. But that's just a very, broad brush overview. But next we're going to talk about how to enable this on OpenBSD, so I will see you there. Okay, so now that we had a little bit of primer of what IP routing is, how we enable it on OpenBSD. By default, OpenBSD will only act as a router between two or more networks if you enable a certain kernel variable. Now, if you don't do this, something important to understand is OpenBSD can only send either to a default gateway or its local network only. So like for instance, it could send to its printer or something like that. But if it's not enabled, it won't route packets that are not sourced from itself. Okay? And the file that controls this is in etc, and it's called sysctl.conf. So we can control multiple kernel variables in that file that control multiple parts of the kernel. But the main one we're worried about is it's called net.inet.ip.forwarding. And we either can set that to 0 to be off or 1 to be on. And that is what we're going to be setting. But we're going to do that in the lab coming right up next. So I will see you in the lab. Alright, in this video we're going to enable IP routing. So as we spoke before, it is configured in etc sysctl.conf, and it allows OpenBSD to route packets. But how we look at this is with the sysctl command. Use a -a, but we're going to use a command called a pipe that will take the input from sysctl-a and let us do other operations on it. So we're going to grep in this case to look for text, and we're going to say the text forward. That's what we're looking for. So we're going to hit enter, and the one we're interested in is net.inet.ip.forwarding. Right now it's 0, so that does mean it's disabled, so OpenBSD won't route packets. To enable this, we want to use the vi command again, and under etc sysctl.conf, we want to type net.inet.ip.forwarding equals 1. So on every boot, that will activate that for us. So if you reboot, it will enable it. To do it without rebooting, you can just simply run sysctl net.inet.ip.forwarding equals 1, and now it is set to 1. So that is how we enable forwarding. And now it'll take a packet from one of its interfaces, look at the destination IP address, and forward it out the correct interface. So I hope you enjoyed that one, and I will see you in the next one. Okay, so now that we've set our IP addresses on our interfaces and enabled routing, we have to talk about how we can control how those packets flow. And in OpenBSD, we use packet filter for that, or just simply shortened to PF. Now, a little bit of background. PF was released in 2001, and it was actually coded because they actually needed a replacement for IP filter. And IP filter was their firewall at a time for a while, until they had some licensing issues. I'm not really going to get very far into that, but they had licensing issues, in other words, and they had to make a replacement to continue having a packet filter in their operating system. So it was led by very many people, and it is a big team effort of that. But one of the big people in there was called Henning Brewer, and he still is involved with OpenBSD, but he is one of the people that helped with it. But I do want to make a point. It is a very big team effort with OpenBSD. It is not one person. It is a lot of people. So the main thing we do is we want to filter what ways packets can travel on our interfaces. So much like a traffic cop, you want to control where cars are going on streets. In this case, we want to control where packets can be routed. So it is a stateful firewall, and that means it remembers key details about connections. So it remembers criteria such as the source and destination IP addresses or layer 3 addresses. It can remember layer 4 information like the source and destination port numbers. It can differentiate on the protocol, whether it's TCP or UDP. It can take note of what interface that packet came in on, as well as what interface it should go out on, and also things like the TCP sequence number. It can keep track of things like that. But that's the stateful portion of it. There's many other features as well. It can do NAT, or network address translation, which is essentially where we can take a private IP address space and make it into a public IP address space, make it appear like it's coming from one, or the opposite, where we can take a public one and make it go into a private one. We can also do quality of service to utilize our bandwidth better and give certain types of traffic more bandwidth while we give others less. We can do anti-spoofing, which is essentially making sure packets are coming in on the interfaces they are supposed to. And you can do even more cool things with connection synchronization using PF sync. And that essentially takes the state table information from PF and it can synchronize it to another firewall running PF or even another server. Even, going outside of the realm of firewalls. It works on servers as well. You can combine two protocols together. You can combine CARP and PF sync, and that can actually give you high availability firewall clusters. So in very critical networks, this is very nice to have to limit the impact of failures. So in the next video, we're going to cover a few more things about PF, and then we're going to go into the syntax of the configuration file. So I will see you there. Okay, so here's a continuation of our last section, our last video. The main rules in PF, how we spoke before, they can either be pass or block. Those are the two main rules we're going to see when we configure it. But those main rules can have sub-rules. So basically like sub-actions that affect how the rule works. So we can have the action of NAT-2. That is our source NAT. So this would be like the equivalent of NAT overload. If you use Cisco iOS, it's NAT overload. Essentially, it just makes a bunch of private IPs appear to be coming from one public IP. You can also do things like redirect-2, so RDR-2. That is destination NAT. So this is port forwarding. And you can take a public address space coming in that doesn't have states yet. If it's going to the right port and optionally from the right source address, it can be translated to go to the private IP address. So if you have a server on your LAN, you can use port forwarding to allow that to be accessed. You can also use rules that are queues. So this is a separate keyword in PF, and we can classify packets for our quality of service policies. So you can get very fine-grained with that and, section off different queues for, say, VoIP traffic that would have a lower delay and higher bandwidth, whereas something like web traffic may not need that much. So you can give it less bandwidth and hold more of those packets back. But you also can use macros, and they can be used to store interface names, port numbers, and IP addresses, among other things. Finally, as well, we can use tables, and those can be used to store large ranges of IP addresses. So many subnets can be efficiently accessed when you are filtering on them, and you can use more efficient use of your memory by doing it that way. But anyway, in the next video, we're going to go over the pf.conf format. I will see you there. Okay, the pf.conf format. So, the rules that control pf by default are stored in etcpf.conf. You can make other versions if you want to. Again, just like with the hostname files, we can make multiple versions to test changes, and then we can use that copy to revert back if something goes wrong. But by default, it's in etcpf.conf. And the logic of how pf is processes packets, or the packet is processed from the first rule to the last rule, so from top to bottom, and the last rule that matched the packet the best wins. So in other words, whether you said pass or block, or you did something like a NAT redirection, so port forward, it will hit that rule and that action will be taken on the packet. But this top to bottom logic is good, but sometimes we need to do other kind of processing, and how we do that is we bypass it with the quick keyword in a rule. So we could say pass in quick, and if there was other rules below that rule, we would be able to just stop the processing right there. So it is a quicker, more efficient way to do that. But we're going to talk about how a basic rule looks. Now, don't freak out if this is the first time you've seen this. This is a basic rule that does source NAT for one address space to a public address space. What we're saying here is we're passing packets out, so we're routing them out. So remember, out means it's routed away from the firewall, out of an interface. And on, we're specifying the EM1 interface. Do keep in mind, EM1 could be referred to by a macro like WAN or external. So you could use that by placing a $ and then the macro name instead of the interface name directly. But when we do the lab, we will talk about that. From is the source, and the source here is the subnet 192.168.0.0/24. The 2 is the destination. This is to any destination. You can definitely restrict that, though, to certain destinations. The NAT-2 does the source NAT, so it changes the source IP address of these packets if they're sourced from this subnet that we talked about. And the EM1 after the NAT2 specifies that you're changing the source address to whatever IP address is on that interface. But the cool thing is, if you have a dynamic IP address like with DHCP and it changes, the parentheses will allow it to automatically update that in outgoing translations. So you won't have to reload your rule set. It will just automatically use the new address. So finally, though, that keep state just tells it to put information about the packet that matches the rule, put information about that connection in the state table, so when packets come back that are part of that connection, they can bypass this rule processing and go through much quicker and less load than having a lookup every time. So the pass in on EM1, a lot of it is actually the same. So how it's the same is the pass does the same thing, but we're saying in this time, so it's coming into the firewall. And another thing is, when you say in, there's usually no state yet either. Out, there usually is a state that made it, that allowed it to come in on an interface to begin with, okay? So we want to pass in on EM1, and we want to say init because that means IPv4. The proto means the layer 4 protocol. In this case, it is TCP. Now, from, again, same thing, that's the source. It's any source because in this case, this is the WAN we're pretending. To the destination IP address, and this would be your WAN IP address on your WAN interface. The port is, if it's 80 in this case, we're redirecting it, so with RDR-2, the internal address of 192.168.0.3, so that is actually rewriting the layer 3 destination address to be going to that address, and then it's making state. So we want to make it go to that address and port 80. And then that will make state in there for us. So that is the pf.conf rule format and how it processes the rules. So coming up next, we're going to get into the lab again and configure this for a basic network. And then we are going to move on to DHCP. So I will see you in the lab. Okay, I decided before we go into the lab, it would be good to talk about some commands about enabling PF. So the main one that is important is pfctl-nf, and then you specify the config file location, so at cpf.conf in this case. And that checks the file for valid syntax. So it makes sure that we didn't make any errors. If we do, it just tells you that, and you can go in and fix the error. But once you've done that, you can do pfctl-f and then your file location, and that actually loads them in to RAM and makes them operate on packets. Other than loading and checking the rule set, we have pfctl-e that enables PF, and pfctl-d, which disables PF. Also, if we want to see information about how many matches per second, how many blocks per second, and things like that, we can use pfctl-si, that shows the statistics. And these are actually short for information, so this is a shorthand way of doing it. The other one, how we spoke about it being stateful, we can look at the states with pfctl-ss, and that shows our states for us. Okay, with that, now we'll go into the PF lab. So I'll see you there. Alright, in this video, we're going to configure the PF firewall. So the first thing we want to do is use the copy command again. They're stored in pfconf, at cpfconf. We want to back it up to another file. Just, again, if you want to make changes and date that file, you can revert back very easily. We're going to remove the original file, and we're going to use vi and type at cpfconf again to make a new one. Now we're going to type I for insert, and we're going to start with those macros like we discussed. We're going to say LAN, and they don't have to be all capitals, just the main thing is they have an equal after them. And you have the quotations. So our LAN interface is EM0, close the quotation. Under that, we're going to say WAN, and then that was EM1. And we're also going to set some runtime options that affect how PF works. We're going to say set skip on space LO0. This stops PF from looking at any packets that are coming in or out of the loopback interface. So we don't usually have to filter packets there. The next one tells PF if it should respond to a sender of a packet that has been blocked. Now you can either respond with reject, or you cannot send any response at all with block. Let's do set block -policy drop. Because in my opinion, if it does not send a reply back, there's less information for tools like Nmap to use. So But you do have other ways of doing it, but we're just going to use block here. Less information, the better. So, again, the processing starts from top to bottom. So the first rule we want to use is block drop all. This blocks any protocol using any interface, any port numbers, and any IP addresses. It doesn't matter what's in the packet. If it hits this rule, it will be dropped. Now, after this rule, if we don't add anything else, nothing will be able to go anywhere in our firewall. So we need to add a rule first to start at the LAN side and let the LAN side traffic in to the firewall. To do that, we want to say the pass in on. Then to utilize our macro, we want to put a $sign there and then type our macro name, so LAN. So that says pass packets in on the LAN interface, which really is EM0. And then we're going to say from, and then we're going to utilize that macro once again and say colon network this time after the macro. That means the network that is assigned to that interface. So in our case, it's 192.168.1.0/24 that's assigned there. And that will be put in place of that when we load PF. Now, from here, we're going to say to any destination, and we want to say keep state. So all that does is pass the LAN traffic in from the LAN subnet and keeps the state, and it doesn't matter where it is going. So now that it's in on the LAN side, we want to pass it out on the WAN side. So we want to say pass out on the WAN from the source of the WAN. I'm sorry, not the WAN network, the LAN network to any destination. But now we're going to use that source NAT we discussed, and we're going to say NAT-2, then in parentheses specify our WAN macro and keep state. Now the last rule we need is to let the firewall itself talk for package management, updates, and other things like that. To do that, we're going to say pass out on WAN from WAN network to any and keep state. Okay, that's the 4 rules we need, and very important to understand with the processing. We didn't use quick in this case. We didn't have to. So we're going to pass in on the LAN side. All right. And then when we pass out, it'll only pass the traffic out from the LAN network because that's all it's coming in to begin with on that interface. Okay. And then we want to change the source of that to the WAN interface's IP address, which is EM1, and put those packets in the state table. Same thing with this side, so we have state on both sides of the firewall. And lastly, we want to allow the firewall itself to talk, and that's what this rule does here. But you notice, there isn't any other pass rules that are passing anything in or out. So that means everything else, even packets coming in from the internet, are going to be dropped by this rule, regardless of what they are. So that is how we set up a basic pf.conf. There's so much more PF can do, but for a basic network and a basic firewall with one LAN and one WAN, this is all we need. So not every network needs queuing and all of that, but this is just, remember, it's that beginner level course. And I'm trying to take you from knowing not much about this to getting your feet wet in it and being able to run off and learn more. So with that, we're going to move right on. And actually, before we move on, I actually forgot. We need to save that file again. So :wq, and we want to test the file with pfctl-nf at cpf.conf. There's no errors. And what we want to do now is use the -f with that file name, and now it's loaded. So to view them, we're going to use pfctl-sr, and they are loaded all up for us. And if we ping, we can still ping. And again, if we look pfctl-ss, we have states for that ping as well. All right, so there's our PF, and that's how we configure it. I will see you in the next one. Okay, now that we have our firewall all configured and working, we're going to talk about DHCP. Now, DHCP is a client-server protocol, and it stands for Dynamic Host Configuration Protocol. The ports that it uses, first of all, it uses UDP for its transport layer protocol, so layer 4 protocol, and it uses port 67 as the destination port for the server. So the server listens on port 67, and 68 is what the client sends from as a source, and as well what the client listens for replies on. It uses that port. So essentially, as a client, we ask the DHCP server for the proper network information, and as a server, we assign the proper network information to the client by giving that client a lease. So that is the basic rundown of what DHCP is providing for us. And in the next one, we're going to go ahead and talk about a little bit more about it. So the main parameters that DHCP needs are the main parameters it assigns are the network ID, the subnet mask, the default gateway, DNS servers, and a domain name. Now there is also optional parameters, and they can include the TFTP server, an NTP server for like your time protocol, and many other things. So we configure IP addresses in a pool or a range of IP addresses. And then when the server gets a request, it takes an address from that pool and links it with a lease. So that lease we talked about for the client. But the leases do expire after a time that we configure on the server. And if we don't configure anything, it will just use the default. But after that, those addresses are released back to the pool if the lease is not renewed. But luckily, though, the client can request that the lease it had before it expires. So you don't necessarily have to worry about it running out. By default, it will request it again. Okay, in the next one, we're going to talk about the dhcpd.conf format. I will see you there. Okay, so this is the configuration file where we tell the DHCP server how to work. And as I said before, how DHCP was one of the functions it had, this is all built in. So the PF and everything we've been talking about is all built in automatically. So it is under etc dhcpd.conf. And the main things that we're going to be putting in this file are in the format option and then a value. So option, in this case, domain-name. That's the domain name that we want to assign to our clients. Another thing that we talked about assigning is DNS servers. So to do that, we would say option domain name servers, and then we would specify first our primary, and then have a comma, and then our secondary server. And we would assign those to clients. They can override those in their own configuration, but we can also do tricks with PF that we could redirect those so they only use certain DNS servers, but I'm getting ahead of myself. Outside of that, to specify that pool, we use subnet, space, and then a network ID. So in this case, it's 192.168.1.0, so the beginning of that network. The net mask is the subnet mask portion. In this case, it's 255.255.255.0. And then you open a curly brace, and then you hit enter. And then inside of this, we want to put the dynamic range. So we put range, and then the starting address, space, and then the ending address. But remember, these addresses have to be in the subnet we specified above, okay? But that's the range of addresses that clients can lease. The next thing is option routers. This specifies the default gateway. So how we said before when we talked about routing, OpenBSD will only be able to send to its default gateway. Well, the clients don't route packets that aren't sourced from themselves. So they have to send to a default gateway, and this is what that specifies. Another important thing to remember, each pool in this is only used if an interface is active with an IP address in that pool's subnet. So, in other words, this will not serve lease IP addresses from this pool if there's no active interface that is assigned an address that's in 192.168.10/24. So you have to have an interface in the subnets you specify in your pools. So with that, we're going to go ahead and move on to enabling DHCPD, and then after that, we're going to get into the lab. So I will see you there. All right, so the basic things for enabling DHCPD. The main command we want to run after we make any configuration file change, or any file at all, is DHCPD space -n, and that tests the file for valid syntax, much like we did with pfctl, but just different command to do it. So the next thing is how we enable and disable the service. So we do that with rcctl enable DHCPD, and we did talk about that back in the admin housekeeping section. And then of course to disable it on boot, we use rcctl disable. Remember, enable and disable enables it on boot. Restart, start and stop manage the running service, not just what it does on boot. So rcctl restart would restart that server. But that is how we do basic management of the service. So in the next video, we're going to go in the lab and configure this. So I will see you there. Okay, in this video, we're going to configure the DHCP server. So the first thing we want to do is use vi again. And under etc dhcpd.conf, we want to create a new file. We're going to start with option space domain dash name, and then in quotes we can put whatever domain name we want. It can be just internal, or it can be an FQDN, fully qualified domain name. We're going to use just test here for this demonstration. And you want to end these lines with a semicolon, and that completes one line of configuration. Under that, we're going to say option domain dash name dash servers rather. And then from there, we're going to specify the first primary, so 4.2.2.1, comma, space. They can be any of them. So for the second one, we'll use Google's 8.8.8.8, and then end with a semicolon. But they can be any public DNS server or any internal DNS server, if you're doing something like split DNS, but it's out of the scope of this configuration. So now we have to specify the subnet pool. So that range of addresses that the DHCP server will lease. To do that, we're going to do subnet space, and then the network ID follows that. So it's 192.168.1.0 on our network, and then our net mask is 255.255.255.0, so a /24 network. Following that, use an opening curly brace here. Enter down. I prefer to enter down twice. It just makes things look a little cleaner. We're going to tab in twice. And now we need to specify the range of addresses that will be able to be leased out to clients. So we're going to say range, and then firstly, we're going to specify the start address of 100, have a space, and then the last address in the range follows that. So 192.168.1.200. End this with a semicolon, and now you have your dynamic range you're going to lease out to clients. And we're going to enter down and tab in again and run option routers space, and then our LAN IP addresses. So our LAN interfaces IP address. So in our case, it was 192.168.1.1, and have a semicolon to end that option. And that does have to be on the same subnet because they're in that broadcast domain, so they have to be able to reach that with ARP. In IPv4 at least. But same thing for IPv6, it's just neighbor discovery protocol. But just to prime you on that. And to end all of this, and again, option routers, to boil it down, remember, is the default gateway. So to end all of this, we're going to do another curly brace to match the one on top, the opposite way though. And we're going to hit escape to get out of edit mode and type :W WQ. And that saves our file. So if you remember, we test it with DHCPD space -N, and there's no output, so that means there is no errors in that file. And we need to enable it on boot, because OpenBSD doesn't start a DHCP server by default. So to do that, we're going to do rcctl enable DHCPD, and then we're going to use rcctl start DHCPD. So now, to check it, rcctl check DHCPD, and it is okay and running. So now we've set up our DHCP server. So I will see you in the next one. Okay, now we're going to shift gears and talk about some day-to-day monitoring we can do when we're logged into our firewall, now that we've set everything up. So, the main commands I use all the time, first of all, would be top. And this command shows which processes are using the most resources on the system. Whether that be RAM or CPU usage, it will show you that. The next one is W. And this shows you what users are logged into the system in real time and what they're doing. And that is helpful not just when you have multiple admins working in your firewall, but when you're trying to see if the firewall has been hacked into. So, next we would use df-h, and that is a space -h, by the way. That shows the disk space used and available, so things like log files take up space. How we talked about installing packages, those take up space. It's a good way to just see how much space you have left. The next thing would be rcctl check and then name. So name is whatever service, like DHCPD or SSHD, and that just checks to make sure it's running. So the other things we can do are something like sysstat space vmstat, and that shows the RAM and CPU usage and even hardware interrupts. So when a piece of hardware needs to interrupt because it has data, it has to interrupt the system, it can send a hardware interrupt. But that shows you all those things in real time, and you can measure how good your system is working. If it's overloaded, if it's underutilized, that's a good way to see that. As far as your interfaces are concerned, a good one to use is a sysstat ifstat. This shows packets per second on all interfaces in real time. So this shows, your bytes per second, your packets per second, your errors you have, your collisions, things like that. And you could also tell from this output if an interface may be going bad if it has a lot of errors, and there's no other way to explain why those errors are there. As far as connections go with programs, network connections, you have sysstat netstat, and that shows connections sourced from the firewall in real time. So if you SSH from the firewall itself to another system, you would see that as an established connection. So that is some monitoring you can do there. And moving on, there is also, as far as network connections, but instead of a live view, we can do a snapshot of it. You can do netstat-an. That shows the active and listening network connections, so you can see if you have any weird servers listening on your machine, or if you, let's say, change the port of SSH and you want to see if the change took. That would be a way you can verify that as well. Another one is pftop. This is kind of like top, but instead of resource usage for your CPU and RAM, this shows your state table in real time. It's very good to see what connections are going through the firewall in real time, as far as the port numbers, how long they've been alive, how many packets they've sent, and things like that. It's very helpful. Another thing for keeping track of your overall data usage is vnstat. and that keeps historic information about the data usage on all interfaces. So that is helpful. One of the best ones you can use as far as analyzing packets and network traffic is probably TCP dump. This shows any packet information that you need in real time. You can filter on port numbers, you can filter on source and destination IP addresses, all these kinds of things, and you can also capture that in a PCAP or CAP file and operate on it later. But those are just a peek behind the curtain of some of the monitoring tools we can use. So with that, coming up next is our bonus content section, and then we'll wrap it up. So I will see you there. Alright, in this video we're going to talk about some monitoring of our OpenBSD firewall. So the first thing we'll do, and for most of these, do make sure you're logged in as root, or again, that you have a user that's a member of the wheel group. What we're going to do first is run top, T-O-P. And this shows us lots of things, but the most important things would be the load averages. So up top, and this basically tells you how many processes are queued up that need resources, and the higher amount of load on the system, the less that it will be able to schedule those processes to run, and that will cause that number to go up. So if it's very high, that may mean your system is overloaded. Speaking of processes though, underneath that you have 30 processes. 29 of them are just waiting. They don't have any information to process right now. One of them is on the processor, and that's actually the top command on there. Under there is CPU. Now the first one is user land stuff, so anything we do in the user land. And then you have nice. You have things that have to do with the system processes. You have spin. And you have interrupt load, which is when hardware needs to interrupt the CPU. And then again you have idle. So at the moment, all of our CPU is idle. And down below that is the memory of the system, so the RAM. So you have the 23 megabytes, and that is active, allocated to processes right now. 297 has been allocated. There's 680 megabytes that has not been allocated to a process by the kernel at all. The cached RAM is RAM that has been used, but it's sitting there to be used again for, any kind of need. It can be reclaimed by the kernel. And the swap space is when we run out of free and cached RAM and it's all active for processes to use. We need to start using disk space to swap out some of those pages of RAM into swap, and then you're waiting to use some of that RAM, and then you need to swap it back from the disk. So when that happens a lot, though, that may mean you need more RAM, but for a firewall with no services running on top of it, just to configure it out, we have it here. That is very unlikely that will ever happen. So that is the basics of top. The only thing I didn't talk about down here in the columns, the PID is the process ID, the username is the rights it's running as, the priority is, I believe, with the nice, and the priority goes with the nice value. The nice is how preferred the process is to get resources and how quickly it will be attended to if it needs to run. And the size is the size in RAM. Resident, again, has to do with the size of it in RAM. The state has to do with what it's doing at the moment, if it is running and processing. The wait state tells you what state in the kernel that the process is in. Time is the CPU time it's taken to run before being released. And the CPU percentage is how much it's using. And finally, the command is the actual process name. Now, the last thing after that is the uptime. So with the up, the system has been up for an hour and 8 minutes. And then we have just our host name, dot, and then our domain name, and the current time on the system. So that is a rundown of how top works and what it can show you. So with that, we're moving right along. Okay, in this video, we're going to show the W command to see who's logged in. So again, as root or as a normal user, you can run W, hit enter, and honestly it gives you a lot of the same information we just talked about with top, but basically it shows the user, the terminal they're logged in from, so console 0 in this case, and if they were logged in over something like Telnet or SSH, you would see an IP address in the from line there, when they logged in Saturday at 11 p.m., how long they've been idle, and what they're doing, and that's the W command, because we're the only user logged in, and we just ran the W command. But if there was other users logged in different ways, doing other commands, you would see it there as well. So that's a quick rundown of what the W command is, how to use it, and what it shows you. So with that, I'll see you in the next one. Okay, in this video, we're going to talk about monitoring disk usage. So as root, we're going to type the command df space -h, and the H is for human readable. Otherwise, you wouldn't have the normal units of measurement like gigabytes and megabytes. So here is the file system column that shows you the device node that the kernel uses to operate on the disk. And the WD0 is our disk, if you remember back from installation. And as well, a quick note, if you have a SATA disk, that would be something like SD, so it would look a little bit different. But the AKD is all the slices inside of that, the partitions. And each one, with the size column, it's the total size of it. The used column is the amount of space that is allocated for files. The available is how much is left to be allocated for files. The capacity is how much of it is used, and the mounted on is where it is logically mounted in the file system. So again, that is the df command and how to read the output. I will see you in the next one. Okay, in this video, we're going to talk about the rcctl command and how to monitor services. So with this command, we did use it already in the DHCP section, and when we did admin housekeeping. But what we'll quick do is, as root, you want to run rcctl, and in this case we'll use check and DHCPD. And again, our DHCPD is running, but that's how you would check a service. Again, we'll quick just to test. You don't have to do these necessarily, but we're starting up another service, and we can run check on SSH, and you can see it's running as well. But that's just how you monitor services. And again, with this one, we're focusing in on the check portion of that, which just checks the status of the service and then returns if it's running or not. But anyway, that's how you use rcctl, so I will see you in the next one. Alright, in this video, we're going to show how to use syststat vmstat to monitor memory on the system. So we're going to, as root, type syststat space vmstat. And again, a lot of this has overlap with what top shows you, as far as things like how the CPU usage is broken down and things like that. But you can also see things like the disk usage, reading and writing of that disk, how we talked about pages of swap. You can see how many pages are swapping in and out with the paging and swapping columns. The active memory is how much in kilobytes that is used right now. So right now there's 25,584 kilobytes of memory, which is 25.5 megabytes. And we can also see we have 306 megabytes of real memory at the moment. And we have quite a bit of free memory at the moment. But down there you see information about the processes, and over on the interrupts column you can see the amount of interrupts. So what you also notice is when we send packets through the system, you will see that your interface cards EM0 and EM1 in the interrupts column will actually show you quite a few interrupts, because it has to interrupt for the packets that are coming across. And then you'll also see the packets, and the alt packet fields have values by them as well. So that's how you use sysstat vmstat. I will see you in the next one. Okay, in this video we're going to use sysstat ifstat and talk about the output. So again, as root, we want to use sysstat ifstat. And this one basically shows you the packets, basically like vmstat did, but it tells you the interfaces you have on the left there in the iface column, their state in the state column. With ifconfig, you can also set a description, and you can also do that in the hostname files. That would be there if you set one. The inbound packets for the interface, the inbound bytes that make up those packets, the input errors of the interface that are coming in, and same for the next 3 columns for the packets that are going out of the interface, the bytes that make up those packets going out, the errors going out of the interface, and the last column for collisions. And then at the bottom, you'll see that it will total them all up for you. And then, of course, the columns up top are very similar to top, so we're not going to go over those again. But that is how this command works. So I will see you in the next one. Okay, in this video, we're going to talk about the sysstat netstat command. So we're going to say sysstat, S-Y-S-T-A-T, and we're going to say netstat. Now, this isn't actually very interesting, but basically, if you had connections sourced from the firewall itself, like you SSH somewhere, or telnet, you would see the local address being your machine itself, the foreign address being the remote address of the other end of the socket, the protocol the program is using, the receive queue amount of bytes to be sent, the send queue of bytes to be, the receive queue that is waiting to be processed by the application, the send queue that is waiting to be sent by the application, and the state it's in. If it was TCP, you'd see established, or something like time wait, if it was tearing down, stuff like that. But that is how the sysstat netstat works, and actually there is one. Perfect. It is an NTP connection to keep time synchronized, and it's using port 123, and that is what you see there when that connects. So with that, we're going to move right along. Alright, in this video, we're going to talk about netstat, but this time without getting a live update of it, just a snapshot. To do that, we're going to say net. There we go. If we say netstat -an, but we're going to pipe this output to the less command so it's easier to see. This is the application's sockets that are being used here. And very, very similar to the sysstat. The fields mean the same thing. And when we're looking at here, we can go down, we can see SSH is running. There's the link local address for SMTP on loopback for IPv6. And these are just streams in RAM for inter-process communication. Not necessarily over the network, just in the same machine. But there you go, and that is netstat. Netstat can do a lot of things, but this is the main, one of the main uses for it. So with that, I will see you in the next one. Alright, in this video, we're going to monitor connections, going the state table in the firewall with PF. So we actually do need to install PF because it's not included on a default installation. So again, we're going to go back to how we did in the housekeeping section. Package add PF top, and that should install it for you provided you have an internet connection, and if you've been following along you will at this point. Okay, now it is installed, and now we're going to run PF top, and real quick, basically it's similar to top but all about the PF state table, all the connections going through there. We don't have any clients on the LAN side right now, but if there was, you would see those as a source as well. No big deal. They would just show up there. But basically the source is how it sounds. The D is for the direction, so it matched a rule in PF that was outbound. The protocol is UDP and TCP there, as you can see. The destination and the destination port number, and the source port number after the colon. This state is both sides of the TCP connection or UDP connection. The age is how long it's been in the state table. The expiration is how long before it will be flushed from the state table. Packets are the amount of packets that have matched that state coming through the firewall, and because they've matched as well, they haven't had to be reevaluated. And again, the bytes are just what makes up those packets. If we do V for view and click that, we can see the long output. And the gateway is important because you can see what gateway the packets are using. And again, the time, as we saw, you could see the amount of size. You could see the rules that are being matched even. Those 4 rules we put in there. And the rule label and all things about the rules, how many packets for each rule. And the speed of the connection can be seen here as well. And of course back to the default view. But that's a quick overview of PFTop. So I will see you in the next one. Okay, in this video we're going to talk about monitoring connection bandwidth with IFTOP. So what we have to do again is install it because it's not installed by default. So package add IFTOP. And once we install, there we go. We can run IFTOP. There's lots of options, but if you use a hyphen, I like to use N so it doesn't resolve DNS names. Capital N so it doesn't resolve port numbers. And then we're going to use capital P so it shows me port numbers, and I for the interface, and we're going to monitor EM1 in this case, so our WAN interface. And if there was connections going through here, we would see the amount, and very similar to NetStats and PFTop as far as the IP addressing information. And it would show you down here the transmit totals, the receive totals, and the totals through the network, as well as the peak rates and the average rate. So, there is one. Again, another NTP attempt. But yeah, there you go. You can see that it shows you that information and some information about that. And if you turn on domain name resolution, it will show you that as well. So with that, we will move it right along. Alright, in this video, we're going to take a look at keeping track of data usage with vnstat. Again, it's not included by default, so we're going to do package add vnstat. And after we do that, we're going to do rcctl enable vnstat d, that enables it on boot, and rcctl start vnstat d. Now that it is started, we're going to try a few pings here just to get some traffic going to try to show you what it's keeping track of. If I do vnstat now at any time the daemon is running, okay, there's not enough data yet, but essentially it'll show you the receive information, transmit information, the totals, and the estimated amount of information. So that's what it's going to show you for all those interfaces, but you do have to run it for, at least if you have a busy network, an hour would be enough time. If you're doing a lot of things like Netflix, YouTube, other things like that, it would fill up pretty quickly. But as time goes on, you'll see it month by month. So it's actually really cool to take store graphs of that. But that is what vnstat is and how to configure it. So moving right along. Alright, in this video we're going to look at using TCP dump. Now unlike the other ones, this is included. So we're going to run TCP dump space and then hyphen and then N to not resolve names for domain names, I for the interface, and in this case we'll specify the WAN, but you could just easily specify the LAN or any other interface. So if we just run it by default, we might not see too much because there isn't much going on at the moment. But this will show you packets. There we go. There's the NTP requests. And you see very much like the other packages we've seen, but this is the raw information of it. So you see the timestamps, the source address, the source port there, and then after the arrow, you see the destination IP address, the destination port, what type of application layer protocol it is, and other technical information about that protocol. But that is how that one works, and we can also see the layer 2 information. If we throw E in there, that shows us the link layer information. So then we get to see the MAC addresses of it as well. There's other options like the ASCII information with the A option. And you can see a little bit more information from there as well. And if there was interesting stuff, you'd see it, but there isn't much in that protocol that you can technically see. It's not like HTTP that has GET requests. But with that is a basic rundown of TCP dump. But one thing I did want to show before we move on is if you use W and then use the the interface, and then W, and then like out for output, that will write packets it's seeing into a file. So if we get any more packets here, we got 2 packets. So that file, if we use TCP dump -R, we can read that file back, even with filters. So you can read the file back, and if you use those same switches, like the N switch, or if you want to use E, you can see the MAC addresses of past output. That is so amazing about TCP dump. So that is something very good about it, and that's a little bit about how to use it. So I'll see you in the next one. Alright, welcome to the bonus content section. We're going to talk about just a few more things in this section that OpenBSD can do for us. First thing that comes to mind is VLANs. Now VLANs are really cool because they allow one or more physical interfaces to be separated into multiple IP networks. So normally if you have a flat network, you have to have the same amount of interfaces for every. If you want 5 IP subnets, you need 5 physical interfaces. But with VLANs, we could use one interface physically and just have 5 VLAN interfaces configured. So it is a logical interface, and we configure it in the hostname files just like before. Next thing is CARP. CARP allows 2 or more hosts to share a virtual IP address that can be switched between in the group. So the hosts in the group can switch between being the master or the backup state and manage that virtual IP address. So you have redundancy, so the clients can always get their gateway. Or switching gears again to servers, you could put it on a web server, let's say, and if that the servers have the same content, you can still access the server even though one of them went down. But next is PF sync, and that, as we talked before, it allows state table information to be synced between them. Also port forwarding, and that is also known as destination NAT, and it allows that public address space to access hosts on a private address space. And lastly is IPv6. This is the successor to IPv4 that allows far more addresses. And it allows other things as well, like as far as security and having better routing options and things like that. But we're going to be going over a small lab of each of these topics. Alright, in this video, we're going to go ahead and configure VLAN interfaces. So they are not actually a physical interface, so they won't show up in ifconfig by default. You'll just see your physical interfaces. But let's say on EM0, we've decided to get a managed switch, and we're using 802.1q to tag the frames into certain VLANs. So we want to make VLAN 10, let's say. And in reality, there would be more, but once you've seen how to make one, you could figure out how to make the other ones. So we want to use vi, etc, hostname, dot, and we want to say VLAN and then the number. Now, you do want that to match to make management easier, so we're going to make VLAN 10 in this case. We want to use the same command for an IP address, so init, and we want to use 10.1/24 mask, and then we want to use the 802.1q tag value, which is going to be 10 when it comes off the switch or when we send something out of this interface. And then after that, we want to actually link this VLAN with an interface, so we'll look at frames at that interface. So we want to say VLAN dev EM0, which is our LAN. Now to bring this up, we're going to say sh etc net start. And then if we do ifconfig VLAN 10, it is active. It has the IP address and mask we put on there correctly. The in cap field says VNet ID 10, which is what we put there. Parent is EM0, which is what VLAN dev is. Last little quick bonus, if you want to use the VLAN interfaces in your PF file, guess what we can do? We could just say something like VLAN 10 or Office or something else, but let's just make it a little more realistic. Say Office, and then VLAN 10. And then if we want to make some rules for that, we could say pass in on Office from the Office network to any keep state, and then we could still pass that traffic out, pass out on WAN from the Office network, and then we could still do the same NAT rules and everything and use the macros interchangeably. So that there would allow that VLAN to be passed out and natted just like before, and that shows that the macros are pretty flexible. And we can do those same things to reload the rule set and view our new VLAN. So that's how you use the VLANs in PF and how to create them in the hostname files. But there's our VLANs. So that's how we create VLAN interfaces, and I will see you in the next one. Alright, in this video we're going to set up a basic carp. So what we'll do first is do an ifconfig EM0, since we want carp on the LAN. You need to make sure the virtual IP that carp uses is inside of the same network on the physical interface you want to use. So you want it to be inside of the 192.168.10/24 network in this case. To do that, we're going to make a file in etc hostname.carp10. The virtual IP is that 1.1/24 mask on that, and then do a broadcast address of 1.255 here. The VHID is 10, and that is the carp group ID. Okay. After that, you want to use pass space carp pass. This secures the carp session between the neighbors, and then carp dev will link these packets to go out of the physical interface. Once we do all that, we can save the file, and we'll be able to do sh etc net start. And if we look, carp should be configured, and in a second they should come up as the master. Okay. And what we can do as well is on the backup, real quick, all we would have to do to make the other node the backup in the carp is here we would want to put ADV skew and then a higher number. Okay. And then if we do that and rerun that, now the ADV skew is 100. We're still the master because there's no other carp instance up. But if the carp instance with 0 was running, they would become the master, and the one with a higher advertised skew would remain the backup unless that master goes down. Lastly, you want to configure PF. Now I will say though, let's take this advertised skew part out so you don't get confused thinking you have to put it on both, because you do not. You just have to put it on the one you want to be the backup in the group. So we'll redo that. All right. Okay, and there you actually have to destroy it. So we'll go through this just so there's no confusion. You do have to destroy that interface and recreate that interface. Okay. And make sure that took, and it did. Okay, now we want to go into the conf file for PF. Anytime you're doing carp, you need to pass that traffic, otherwise it'll hit the block drop rule. So we want to say pass proto carp. We want to check that file. And actually, we do want to check the file here with the NF again. And then we want to load those rules. And there we go. So now, if we were to look at EM0, there is our CARP advertisements going out. And if there was another CARP speaker, they would see it, and we'd be able to manage that virtual IP if we were in the same group with the same password. But that's how we do a basic CARP setup, and I will see you in the next one. In this video, we're going to set up pfSync. So this actually goes hand in hand with CARP, so instead of just the virtual IP failing over, we can have the state table for the firewalls fail over as well. So what we'll do is vi etc hostname.pfsync0. Okay, in there we're going to say up to bring the interface up, and then we're going to say sync dev. We have to specify the physical interface we want these updates to go over. In this case, it's the same interface on the LAN that's running CARP. So EM0. And then we want to say sh etc net start. And if we check pfsync0, it is running, and the sync dev is EM0, which is what we want to see. And from there, we can do a TCP dump and see those packets going out. So we have the CARP ones, and occasionally we will see as well the pfSync ones. Now, in reality, it is recommended to do a dedicated interface for pfSync, and in that you would do an IP address for it and pfSync on that interface specifically. So the only difference would be, it would be like EM3 having its own IP, and then you would point pfSync to EM3. But other than the interface config, that is the same, except you just configure another hostname file for a separate interface, and then pfSync on that interface like we just showed. The only other thing we have to do is pass that traffic for pass proto pfSync. Check our configuration again. Load our configuration. And then we'll look again. And now there is our pfSync traffic, because it was being blocked by the block drop all. So it does work well to do it like that. But there we go. That is how we do this here, and how we set up pfSync. So I will see you in the next one. In this video, we're going to set up a port forward with pf. So we want to vi our etc pf.com file. And at the bottom of this file, we want to put in pass in on our WAN interface. We want to say init proto TCP from any source to any destination. The port is going to be 80, and then we're going to say redirect, so RDR-2, and then we're going to pretend the server is at 192.168.100, and its port is 80, and then we're going to specify keep state. Now that passes it into the firewall, but we still have to pass it out of the firewall. So below that, we're going to say pass out on the LAN interface init proto TCP from any to that IP we specified, 192.168.100, port 80, and keep state. So at that point, we would save the file, and then we can do our same checking on it real quick, and then you can load it with that same command and view it the same way. So that's how we make a port forward in PF, and I will see you in the next one. Alright, in this video we're going to configure IPv6. Now to do that, we want to go in those actual same files that we did before. We're going to go in our WAN interface on EM1. This is provided your ISP does provide IPv6 at this point. So we're going to do init 6 space auto conf. it's the escape key and save the file. And then we're going to say sh etc net start. If we do ifconfig on the interface, we just put the configuration in. You'll see a link local address. And this allows things like neighbor discovery protocol to work, as well as IPv6 routing protocols and other things. But that does allow stateless address auto configuration to work as well. But if there was that on the other side of the link sending out the router solicitation messages, we would be able to get our network prefix and use EUI64 to generate an interface ID from our MAC address. But in this case, in the lab, we don't have that, but that is how you set up your interface to be ready to handle that. For Slack, that doesn't set up your DNS servers, though, or your default gateway. From there, though, we do have to allow that traffic through the firewall. So for that, we want to say pass out on our WAN init 6 keep state. So it passes all that traffic out. And then any reply traffic as well. Because periodically we will send a solicitation message as well for that. So when we load that, now we can use IPv6 when it becomes available. So with that, that's how we configure IPv6. Well, congratulations. You made it through the course. So if you followed along through everything, you should have a pretty functional OpenBSD firewall at this point. I do hope you enjoyed this course, and I do hope it helped. But here are some resources for you. First and foremost is www.openbsd.org. That's the main website for OpenBSD. And as well, the man pages are at man.openbsd.org. But also, if you're logged into your system, you can just type man space and then whatever command you want to know. Or if you want to search by keyword, you can do you can do man space -k space and then whatever word you're searching for. You can see the source code for OpenBSD at github.com/OpenBSD. You can donate to OpenBSD at www.openbsdfoundation.org. And to get more information about OpenBSD in general, you can go to en.wikipedia.org/wiki/OpenBSD. You can also go to just the in general Wikipedia. I believe those pages have been translated as well. But with all that, I do hope you really enjoyed this course and found it useful. And I would really like to thank you for the opportunity to teach you about OpenBSD firewalling. And I hope that it helped. And have a very nice day.